All right, so 334, number 2. So let's do this one together, and then you're going to try 2 of the problems from 339 that you might not have done yet. So here's a graph. It's obviously not a quadratic, so it's a polynomial, and we're going to put together the pieces. So how can I figure out the lowest possible degree? I usually look at the end behavior, so I know it's even, right? So x squared, x to the 4th, x to the 6th. Then I also look at the number of turning points. So this has 1, 2, 3 turning points, so it can't be quadratic. So the lowest possible degree would have to be 4, right? X to the 4th, if it has 3 turning points. And then it says determine the sign of the leading coefficient. What part of the graph do you look at for the sign of the leading coefficient? The right side, right, is pointing up. So does the leading coefficient have to be positive or negative? Positive, good. That's kind of a big idea that we've looked at this year. Quadratics, polynomials, transformation rules. All right, find all the x and y intercepts. So let's see, I've got an x-intercept at -4. I have another x-intercept at -2. My last x-intercept is at 1. And what's my y-intercept? It looks like -8. 0, -8. So just being comfortable writing coordinates correctly. I think that's something we struggled with at the beginning of the year, but hopefully being consistent how to write an x-intercept versus a y-intercept. To me, that's kind of a big idea from algebra. Determine all the linear factors and their multiplicities. So would any of these have an even multiplicity and why? Or else they're all going to be odd, right? Remember, they cut through or bounce off. So which factor will have an even multiplicity? Which one? What? At -2, it's bouncing off, right? So my factors are going to be x plus 4, right? Because if -4 is an x-intercept, x plus 4 has to be a factor. And then at -2, it'll be x plus 2 squared, right? Because the -2 gets plugged in to get 0, and we said it had an even multiplicity. And then this last one would be x minus 1 as a factor, because when I plug in 1, it gives me 0. So this is not quite my finished equation. I don't write a factor for my y-intercept. I'm actually going to use the y-intercept to help me solve for the stretch factor of this polynomial. So it'll be y equals a, the stretch factor, times x plus 4 times x plus 2 squared times x minus 1. So just like when we did the catapult, we had to plug in an extra point to figure out our stretch factor. We're going to plug in the 0, -8 as the other point on our graph that we can identify. So I'm going to plug in -8 for the y value and 0 for all these x values. So that would just give me 4 in that parentheses, 2 squared in that parenthesis, and -1 in the last parenthesis. So to solve for a, I have to multiply together 4 times 2 squared times -1. How much is 4 times 4 times -1? Yep, so I'm going to divide both sides of the equation by -16 to solve for a. See how that gets a by itself? So a must be positive 1/2 because -8 divided by -16 is positive 1/2. Remember we said the leading coefficient has to be positive? That's why I asked you that question, just so that you wouldn't make a mistake with the negatives. So your final answer is just that whole equation again, x plus 4, x plus 2 squared, x minus 1, but you just throw that 1/2 in front. So you just built an entire equation by looking at a graph. End behavior, degree, factors and zeros, multiplicity. To me, that's putting together a lot, synthesizing a lot of information, so think about where you came from. maybe needing to review linear functions to working with higher order polynomials at the end of Algebra 2. Pre-calculus starts at polynomials and keeps building. So you've got quite a bank of knowledge